Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the constant equation and movable pulley. Student, if you follow my class attentively and watch my video regularly, then I can assure you that you must crack the iitjee exam and Neet exam confidently with a good rank. Now let's start about the class. Here, I draw the three figure. Suppose this is a rod is placed against a vertical wall. This is a vertical wall, this is ground, this is a rod is fixed. Now at the instant when this end has the velocity, suppose 20 meter per second, then what is the velocity at that moment of this end? So this is the problem. Suppose this angle is 30 degree. Now that is, we have to find the relation between velocity of two blocks which is tied by string, or this is a rod. So first we know what is the constraint mean. What is the constant mean that is a condition is applied, that is motion of one body is dependent on other. Motion of this body cannot move freely. The velocity of this body dependent on this velocity of the body. So here also this velocity of this block is dependent on the velocity of this block, because the whole systems are tied by string. Motion is constraint means motion is restricted. This is the meaning of constraint. Motion of one body is dependent on other, that is motion of body is restricted. So this is the constant equation. This is the constant equation. This is the meaning of constant, means body cannot move freely. So in this type of constant equation, if you are asked that this end moves with a velocity this, and at that moment what is the velocity of this end, this type of problem can be solved by three methods. I will tell you the best method which is applied. Now first discuss the three method. First method, let this is x, and this is y. So and length of the rod is L. So length is constant. Length of the rod is L. Length is constant. So relation between x, y, L is this x square plus y square equal to L square. Now if we differentiate once, L square derivative is 0. Differentiate with respect to t, because we know dx by dt equal to velocity. So dx by dt, this is x, so the velocity of this end is called va, that is x into 20 and y into dy by dt. We have to find the velocity of this end, that is dy by dt. What is this? So dy by dt equal to 0. Now dy by dt equal to minus 20 x by y. Now what is x by y? X by y equal to y by x equal to tan 30, that is 1 by root 3, that is x by equal to root 3. So this is my answer. Now we take the distance y in this direction, so negative comes here, so that means the velocity of this end downward. The velocity of the end is downward. This is one method. By differentiating we get this result. Second method is this, that is the rod is constant, so relative velocity of rod is 0. Relative velocity of rod is 0. That is, suppose this is a point on the rod, this is a point on the rod. Now we take relative velocity of rod along the rod, relative velocity of particle, of every particle. Now second method, velocity, relative velocity of every particles, relative velocity of every particles of rod is 0. That is, if we take a point A, if you take 2 points this and this, then relative velocity of this point along the rod, along the rod, so this degree and this is 30 degree, so relative velocity, so velocity as here, relative velocity along this direction is 20 cos 30 degree, and this is velocity VA. Suppose this is A, this is B, so velocity is VB, and this angle is 30 degree, 90 degree, so this is 60 degree. So along this velocity is VB cos 60 degree. So relative velocity means this minus this, relative velocity of this point and this point means VB cos 60 degree minus 20 cos 30 degree equal to 0. That is relative velocity along the rod, relative velocity of two particles along the rod, relative velocity of two particles along the rod is 0. That is VA cos, if this VB cos 60 degree minus relative velocity means minus this is 20 cos 30 equal to 0. That is VB equal to root 3 by 2 cos 60 degree half, that is 20 root 3. So we get the magnitude of VB directly. So this is the second method, that is relative velocity along the rod. Here relative velocity along the, we take relative velocity along the string will be 0 because the rod length of the rod, here length of the string is constant, it does not change. So if there may be relative velocity present, if there is relative velocity present, then the string will increase, length of the string will increase or decrease, or string or rod will be broken. So that's why relative velocity between two particles along the rod or string is always constant, is always 0. Relative velocity of two particles along the rod or string will be 0. So this is the second method, that is we have to take relative velocity of two particles along the rod or string, and that will be 0, so from that we get the velocity of VB. Now third method is, if summation of tension dot V velocity, tension dot velocity equal to 0, we apply this theory, tension dot velocity vector equal to 0. Here dot product, we know A dot B equal to AB cos theta, this is the vector method dot product. Here theta is angle between tension and velocity, so if we apply this theory here, now tension of the rod is this T into velocity is 20 into angle between T and V is, this. If this is 30 degree, then this angle is 180 minus 30, that is cos 180 minus 30, plus this tension is along this direction, T into VB into cos 60 degree equal to 0. That is T into 20 cos 150 equal to minus cos 150, cos 180 minus theta minus cos 30 minus cos 30 plus T into VB cos 60 degree half. So cancel TV, we get VB equal to 20 into root 3 by 2, half cancel. So this is the answer. So we get this. So any method we get the velocity of B equal to this, the third method. So I recommend this method. This method is best. So this is the best method. We take the summation of all particle, summation of tension and velocity vector, dot product of tension and velocity vector of every body, along the string will be 0. This is the best method. Now if we apply this method at here, at blocks moves with its velocity, suppose 20 meter per second, this angle is 30 degree. When this angle is 30 degree, what is the velocity? What is the velocity of this body? What is the velocity of this body? Now here string is same, so tension remains same. As the string is same, the tension remains same. So what if we apply this method, t into 20 cos 0 degree, because tension and velocity in same direction, t and v. Okay, now here what is the direction of tension? Tension is this direction and this direction. So here t, this angle is 180 degree, so cos 180 degree, t into 20 into 120 degree. Velocity is in this direction and tension in this direction, so angle is 180 degree. So ta cos theta, a dot b means a b cos theta, plus this is t into vb into cos 30 equal to 0. So cancel t. Now we get vb equal to minus 20 cos minus cos 30 root 3 by 2, that is 40 by root 3. Now we take the magnitude. We take the magnitude. So cos 180 minus 1. Now cos 180 equal to minus 1. So 20 equal to vb cos 30. So vb equal to 40 by root 3. So this is the answer. So v and vb direction will be same, because we take this is positive, so vb also positive. So that is this and this direction will be same. Now if we apply this method at here, what we get? What we get here? Suppose this block is a and this block is b, and what is the relation between velocity of a and b? Suppose this block move with acceleration. Now this method, t dot v equal to 0, and also we can apply tension dot acceleration equal to 0. So if you are asked that what is the relation between acceleration of between two blocks, we can apply also this method, t dot a equal to 0. Suppose you are asked that what is the relation between acceleration of a and b. Suppose two blocks moving with downward within acceleration a1 and a2. Now if we apply this method, so first we is of this block, tension of the string is t here. So this block is attached with this pulley. So now this block is moving downward, so 2t into a1 cos 180 plus, now this block also moving downward, so 2t into a2 cos 180. We take the angle between tension and acceleration. The tension upward, acceleration downward, so angle is 180 degree equal to 0. So 2t cancel, so a1 plus a2 equal to 0, that is a1 equal to minus a2. So if the block is moving downward, then this must be move upward, or if the block is moving upward, this block move downward. So this is the relation between a1 and a2. Peacefully, now this angle is theta. This is a vertical line I draw, is a vertical line, just this is not string, a vertical line I draw. Now this is a block. Now if this angle is theta, now what is the relation between u and v? Suppose this block is moved upward with velocity v. What is the relation between v and u? Summation of t dot v equal to 0, that is tv cos theta. Summation of t dot v equal to 0. Now here tension the block is moving upward, this and this, so tension of this in this direction, tension in this direction, and here t is upward. So if in the direction of tension, if you confuse the direction of tension, direction of tension is always upward. Direction of tension is always upward towards the pulley. This. So direction is this direction, this. Direction will always towards the fixed pulley. Direction is always towards the fixed pulley. So you can apply now. If we apply this method, so T is this direction, U is this direction, so angle is 180 degree here. So 2 T into U into cos 180 plus T here, T into here T, this is V, T into V into cos theta. Also this here T into V into cos theta plus here T into U into cos 180 equal to 0. Now this is minus T U cos 180 equal to minus 1, so equal to 0. If we cancel 2t both side, so U equal to V cos theta, that is V equal to U by cos theta. Generally make mistake that this is velocity U, so component of this velocity is this, that is student generally makes mistakes that U cos theta equal to V, but here answer is V equal to U by cos theta. V equal to not U cos theta, V will be U by cos theta. This is the answer. Student generally makes that, so this is U, so this is U, okay, but U cos theta not equal to V. Always if we apply the second method, that is relative velocity along the string, then we can get easily, because relative velocity along the string is 0. So relative velocity, so if the block moves V, what is the velocity along the string? Along the string velocity is V cos theta. Now this moves with V cos theta, this is moves with U, so relative velocity is V cos theta minus equal to 0, that is V equal to U by cos theta. So from second relation we can get also this result. Now here three diagram are given. What is the relation between A1 and A2? So study this diagram. What is the relation between A1 and A2? Very easily we can get relation between A and A2. Although these system are complex, but we can, if we can apply that summation of T dot V equal to 0, this will be very easily we can get this. Here we have to find the acceleration, so T dot A equal to 0, we can apply this. Now what is the tension between tension of the string? Now if this tension is T, suppose if this tension is T, then this is T, so this is 2T, now T, that is tension of this string is same, that is this string is same, so tension along the whole string is same. This string is same, so tension along the whole string will be same. So this is same string, so tension along the whole string will be same. Now the tension becomes T, so this is T, 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 so this is T. I have told that the tension of this string will towards the fixed pulley, that is towards the fixed pulley. Tension will always towards the fixed pulley or fixed point. So this is fixed, so tension will be in this direction. This is fixed pulley, so tension will be in this direction. So from that is tension is always towards the fixed pulley. If you confused about the direction of tension, then remember that tension of the string we will always towards the fixed pulley. Now what is the relation between now if we apply this, then what we get the result? Here 2t, here 2t cos, so here the result is the mass will move downward, so tension will be in this direction. So this is 2t, this is 2t, this is 2t. So now here if we apply this value, there is 2t into a2 cos 180 plus 2t. Total here tension is 2t, 2t, 2t. Total tension act on the mass is 60. So total 60 into a2 a1 into cos 0 degree, because tension and acceleration in same direction, so cos 0 degree equal to 0. So we get a2 minus a2 plus 3a1 equal to 0, that is a2 equal to 3a1. So this is the result, a2 equal to 3a1. So by simple method we get this result. Different tension between the block, this is M. So if we apply the tension, now this is T, this is T, this is T, so this is T. Now this will be 2T, this will be 2T. So the string is same, this string is same, so tension 2T is along this direction. So if this will accelerate in this direction, the block will move in this direction. Suppose this is A1 and this is A2, so this is move in this direction, so tension will be this direction, 2T 2T. Now this also, now this is 2T 2T, so this will be 40 40. Now this is 40. I have told that tension is always towards the fixed pulley, tension of the string is always fixed pulley. So this is 40, this is 2T 2T, this is T, this is T. So if we apply now T dot V equal to 0, if we apply now T dot A equal to 0, what we get the result, T into for mass M, T into T, here T is in this direction and acceleration is along this direction, A2, T into A2 cos, T into A2 cos 0 degree plus here total, what is the total mass of the what is the total tension acting on the block of mass 2m, the total tension is 40 plus 2t, this is 40, this is 2t, this is t, total 4 6 7 7t into a1 equal to 0. Now this is cos 180, so angle is cos 180, because tension act upward direction and acceleration in this direction, so angle between t and a1 is 180 degree. So this is, now this equal to 0, if we cancel this, a2 equal to 6, total is 40 plus 2t plus t, that is 70, total 70, total 40 plus 2t plus t 70, 70 equal to 0. So a2 equal to, so a2 equal to minus 7 a1. So if this, so this is 2m, this is m, if the block moves with acceleration a1, what is the acceleration of this block, a2? This is the question. So we apply this t dot a, we apply for this problem t dot summation of t dot a equal to 0. Now what is the tension of the different string? Tension becomes, suppose this tension along the same string will be same, that is if this is tension t, then this is t, so this becomes 2t t dot a equal to 0. Now this is for this block of mass m, this t into a2 cos 180 degree, because cos 0 degree, t into a into cos 0 degree, plus if we apply t and t dot a on this block, then total tension is here 40 2t and t 70 into a1 into cos 180 degree equal to 0. From this we get a2 equal to minus 7 into a1, 7a1. For this problem, now for this problem, here this pulley is moving upward with a velocity this, and this block is moving downward, this block is moving upward. What is the velocity of this block? So in this type of question we apply general formula, velocity of pulley equal to va plus vb by 2. We apply general method, this is the general formula. Velocity of pulley will be, suppose this is a pulley and two blocks A and B are suspended from the string with the suspended by the string. Now if the pulley is movable with if the pulley is moved upward with velocity Vp, so what, and this velocity is Va, Vb, then we can apply the formula Vp equal to Va plus Vb by 2. If one block is moving downward, we always take the vector addition. So if all the block and pulley move upward with same direction, then we take this is j, so Vp j equal to Vaj plus Vbj by 2. So simple, we get plus or minus, that is Vp equal to Va plus Vb by 2. So when all blocks and pulley moving upward, then we take the simple this formula. And if one get reverse direction, if the direction of one block is reversed, then we take negative. So we apply this formula. Now we apply this formula. Now what is, if we apply this, then upward direction is positive. So just velocity of pulley is 12 is given. Velocity of, suppose this is first we take the velocity of this. So velocity of this, from this we get velocity of this. Suppose velocity of pulley Vp, we have to take velocity of Vp, pulley 1, and this is pulley 2, Vp2. Pulley 1, what is this? Vp1 equal to upward, suppose this is A, this is B, Va downward, Vb upward 4 by 2. So from this we get -1, that is velocity of this pulley move downward with, this pulley is movable with a velocity 20 meter per second, and two blocks, this block A and B, this block moving downward with a velocity 15 meter per second, and this moving with upward 10 meter per second. This is moving and this moves. So if this diagram is present, in this problem, suppose what is the velocity of A and B, what is the velocity of A and B with respect to pulley. So this velocity from the ground, this velocity when observed from the ground, then this is the velocity, that is this velocity are with respect to the ground. If a man observe from the ground, then he then with respect to this man, velocity is this. Now what is the velocity of block A and B with respect to pulley? If a man is on the pulley and pulley is movable with velocity 20 meter per second upward, then with this man, what is the velocity of block A and B? That is, at what velocity the man can observe, that is for what velocity the block A and B moves with respect to this man. Now for this problem we have to, this is relative, so velocity, we determine the velocity of A with respect to pulley. Now from relative velocity we know Va minus Vp. So Vap, we have to find Va minus Vp. Now if this direction we take positive, then this direction we take negative. So Va means Va is positive, suppose negative, minus 15 minus Vp is positive, so 20. Now what result? Minus 35. So minus 35 means that is with respect to this, the block A is moving with 35 meter per second. So this is relative velocity. Now what is the velocity of block B? Velocity of block B with respect to P equal to Vb minus Vp. So if we take Vb equal to 10 meter upward, so this is positive, minus Vp equal to minus 20, that is minus 10 meter per second. So this block also move downward with respect to this pulley, that is this block also move with downward this velocity 10 meter per second when when we observe from the pulley, the block A and B move with this velocity and this velocity. So this is the relative velocity with respect to p. So just apply the formula of relative velocity. This, if you know the relative velocity, then this problem is not difficult. Just apply the formula of relative velocity. Now in this problem, the problem is given here. Just watch this figure. In this figure, if the pulley is, if the string is moved with velocity 8 meter per second downward, then what is the velocity of this block in this system? If the string is pulled downward with velocity this, what is the velocity of block A? Okay, now here I in this problem two method, I explain this by the two method. First method is t dot v equal to 0. First method we apply t dot v equal to 0. First method is this. Next I will explain with the method of vp equal to va plus vb by 2. So first method I explained this method. Now in this problem, what is the tension? Suppose this tension is T. Now what is the tension of this? This is also T. Now this tension will be 2T. So this tension will be 2T. So this will be 40. Now this will be 40. So now if this tension is T1, now what is the relation of T and T1? 40 equal to 2T1. We get 40 equal to 2T1. If this is constant velocity, then tension this is in equilibrium. So 40 equal to 2T1. We get now T1 equal to 2T. Now if we apply this formula, that is 8. Now here velocity is in this direction and tension is upward, so pull upward, so tension is upward. So T1 T into V into cos 180 plus here this block. Now this block moves with tension T1. So here T1 into VA into cos. What is the tension and velocity? Suppose this is tension, this is velocity VA. That is, so if the string is pulled downward, then this pulley will be moved upward. If the pulley move upward, then then this block move upward. So VA T1 VA cos 0 degree. Equal to 0. Now T 8 into T cos n T minus equal to T1 into VA. So this will shift this here. So VA, then now put T1 equal to 2T here. So VA equal to 4. So we get VA equal to 4. That is, the block will move upward with velocity this 4 meter per second. Second method, that is, if we apply this method, Vp equal to Va plus Vb by 2, this method. Now, so suppose this is pulley 1, T1, pulley 1, this is pulley 2, pulley 3 and pulley 4. For pulley 1, for T1, what is the velocity of Vp1 equal to minus 8 plus 0 by 2, because this string is moved downward and this string is fixed, so velocity of this point is 0. Now this is equal to minus 4. Now for pulley P2, Vp2 equal to, for pulley P2, this pulley Vp2 equal to, what is the velocity of this velocity is this minus 4. and this is fixed with the ground, so this velocity is 0. Now minus 4 plus 0 by 2, that is minus 2. That is, this pulley also move downward, minus 2. Now this pulley move downward, that is this pulley move upward. Now for this Vp4 Vp4 equal to 0, this is fixed, 0 plus Va by 2. Now Vp4 equal to, we get the Vp4 is the Vp4 means this thing, velocity of this minus 2. So Vp4 equal to minus 2 equal to Va by 2, that is Va equal to minus 4, that is velocity minus 4. So magnitude of the velocity is 4. So by this method we also get Va equal to 4, Va equal to 4. Okay, if this pulley is moved upward, if this pulley is moved downward minus 2, then this pulley is moved upward, so we get Vp4 equal to plus 2, plus 2, plus 2. So that's why we get V equal to 4. That's Vp2 equal to, this is 0, 0 plus this is minus 4 by 2, that is minus 2. So Vp2 equal to minus 2. Now the pulley move downward with velocity minus 2. This is fixed pulley, this is fixed pulley. So if so this is minus 2, then this is plus 2. This must be plus 2 because this is pushed pulley. So if we get this is velocity minus 2 downward, then this move upward. So how we get this is minus 2, this velocity, if the pulley move downward, then this pulley move upward, how we will get, that is velocity of P3. For P3 velocity of pulley is 0. So if we apply V, suppose this is, we don't know the velocity V1, and this velocity is minus 2 by 2, that is V1 equal to 2. That's why we get, that is velocity is positive plus 2. Now for pulley P4, what is the result? For pulley P4, what is the result? This is Vp4, this is fixed, 0 plus Va by 2 equal to plus 2. This is the velocity of the pulley P4 plus 2. So Va equal to 4. That is block A moves with velocity 4 upward. Velocity upward. Now what is the this problem? For this problem we apply T dot V equal to 0. So what is the velocity, tension? Tension of this is T T T T T T T T. So because thing is same, so tension will be same. Block C, what is the tension? Tension is 2T, and velocity is 0.5 cos 0 degree, because tension and velocity is along same direction, and this is fixed pulley. Now next we apply for block B. So that is T into B is for the block ABC. For the block we take T dot B, that is velocity of what? Velocity of the block ABC. So that's why we take T dot B of the 3 blocks, summation of the 3 blocks, summation of T dot B of 3 blocks. So for this is this. Now for this is what? Here 2T into velocity of Vb we don't know. Suppose this is Vb, we don't know what the result, cos 180 or cos theta. Suppose we get cos theta, angle we don't know, plus now this is 1 meter per second downward, so and tension T upward, so this is T into 1 into cos 180 equal to 0. Now 2 into 0.5 1 plus, so this is T 0.5 into 2 1, this is minus T plus 2T Vb cos theta equal to 0, that is Vb equal to cos theta equal to 0, that is Vb equal to 0. Here Vb theta either 180 degree or 0 degree. So Vb equal to 0, 180 or 0 cos 180 or cos 0 means, that is this result is 0 means Vb equal to 0, because this is not 0. This angle theta is 0 degree or 180 degree. So this is not 0, so Vb equal to 0. Now if this result is positive, then we can say that theta is 0 degree, and if this result be negative, then we can say that theta is 180 degree. Theta is 180 degree means, that is 180 degree means, that is tension is upward, velocity move downward, and theta is 0 degree means velocity of block B upward and tension is upward. Problem is that suppose a wedge is present here, this is a wedge, and a vertical support is here, and a rod is moved in this direction. So this is a vertical support, this is a vertical support, and this rod moves, this is a vertical support, this rod moves on the wedge along the perpendicular this way, that is this surface, and this rod is perpendicular, and this is wedge and this is rod. So if this angle is alpha, so find the wedge moves in this direction, because this movement is only along the ground, and if the rod moves with acceleration a1 with respect to wedge, what is the relation between a1 and a2? Also this also given, sometimes this question also asked, suppose this support is normal to this, and if this angle is theta and rod is this, suppose this is rod, this is wedge. Now if the a1 is acceleration of this rod with respect to this, and acceleration of wedge is this, what is the relation between a1 and a2? So this type of question, what is the theory? Theory is that, what is the theory? Theory is that along the contact face, along the contact surface, normal of the contact surface, along the normal of contact surface, there is no relative acceleration of two blocks. This is the theory. Along the normal direction of contact surface, there is no relative acceleration. There is no relative acceleration of the two blocks. There is no relative acceleration of two blocks or system, two bodies. So we have to take normal direction of contact surface. First select the contact face. So this is the contact face. We take the normal direction at here, in this direction. So now what is the a2? A2 is in this direction. A2, this is alpha, so this angle is alpha. So this angle is 90 minus alpha. So component of a2 along this direction is a2. This is 90 minus alpha. If this is alpha, then this angle is 90 minus alpha, because this is 90 degree, this is 90 degree. Okay, so if this angle is alpha, this is 90 minus alpha. So this direction, this component is a2 cos 90 minus alpha, that is a2 sin alpha for this component of a2 along this, and a1 is completely in this direction. So relative acceleration is this minus this, that is a1 equal to a2 sin alpha. This is the result. So if we apply this theory, then we can get the relation between a and a2. Here acceleration of this block is along this direction, and a2 is this direction. So if we select the contact surface, then this is the contact surface, and we take the normal of the contact surface, that is this. Normal of the contact surface is this. This is the contact surface, and normal of the contact surface is this. So theory is that if this angle is theta, now this is theta, and this is 90, this is 90 minus theta, so this is theta, this is 90 minus theta, and this is theta, and also this is 90 minus theta. So a2 component of a2 along this direction is what? a2 cos 90 minus theta, that is a2 cos 90 minus theta is along this direction, and a1, what is a1? a1 is along this direction, so component of this is a1 cos theta, because this is a1, because this is a1 component of a1 along this direction is a1 cos theta, so we get a1 equal to a2 sin theta by cos theta tan theta. So this is the result. For this case this is the result, and for this case this is the result. So select the contact face first, select the contact surface and take a normal direction of the contact surface, then take the component of different acceleration along the contact, along the normal of the contact surface, the relative acceleration will be 0, so apply this. So this is the result. Student, this is the end of the class. To get such type of video and to continue my theory, subscribe my channel. Okay, thank you.